Hello everyone. My name is Vasu Singhal. I am from ABES Engineering College. I am an AC branch fourth year. I have completed the IoT internship from Emertxe Technology. Table of content. Introduction, objective, component description, methodology, simulation, conclusion. Introduction. I have done the project home automation in this internship. Automation means operating automatically and independently, controlling home appliances automatic or remotely. In this project, we control the light, cooler, heater, and water tank. We using the IoT for communication. What we learned in this internship: C programming, embedded system, IoT, and Blynk app. Let's start with C concepts. Data type: integral and floating. Integral means char int. Floating means float double. Conditional constructor: single and multi iteration. Single if switch case, multi for while do while. Jump statement: break and continue. Operators: arithmetic, relational, logical, bitwise. Operators: symbols that instruct the compilers to perform specific arithmetic or logical operation or operand. Array: array is a specified size of matrix it defines. Array is a collection of data of the same data type. First element, which is the lowest address, and the last element is the highest address. Indexing of arrays start from 0. Should be and size of -1. Pointer, referencing, dereferencing. Pointer means returning more than one values from the function. More concepts. Function. Function, it's a relation or expression involving one or more variables. Input, output operations are three parameters. Recursion, calling a function inside itself. Recursion is a process of repeating items in a self-similar ways. In the programming of functions, calling itself is called a recursion function. String. String. The sequence of the characters is a built-in. It easily store the ASCII values. End of the string is marked with the special character, null character, /0. Storage of classes. Intern, static local, static global. These are storage classes. Header files. Header files is a file containing C declaration and Markov definitions to be shared between several sources of code. C preprocessing directives is hash include. Now go to next point, embedded system. Any combination of hardware and software which is intended to specify a task can be controlled the embedded system. It is basically microcontrollers and the code which is run by other IDE. Types: standalone, real-time, network, mobile. IoT, Internet of Things. Nowadays everything is cloud connected. Backup is also cloud conductor. All things are connected to digital. All things are saved in the other cloud and controls all things by internet is all IoT. Architecture of IoT. Inflection point. Nowadays the hardware is getting cheaper because it's a smaller and IoT. Connectivity. Software is more advanced. Cloud cost, flexibility. Technical requirement. Many devices is connected, large scale, security of the data, volume of data, challenges. Address addressing scales, connectivity, data modules. First principle is addressing scale, connectivity, data size, cloud storage as well. In a Blinkit app, we use this Blinkit app to create the new template, how to add a device, how to select and add a data stream, how to include Blynk library. Objective of this project: aims and goals: to control the cooler and heaters remotely, to control the LED during the day and night, to control the water tank through the internet, to create the home automation system. Project statement: IoT-based home automation solution. Project requirements: project requirements is a tool, hardware and software. In the hardware is LCD, Ethernet system, shield, temperature system, LEDs, light depending register, LDR. Software requirements is Arduino IDE, PICSIMLAB, Blynk app, internet. LEDs. LEDs is basically a semiconductor device which emit the light through the electric current flow through it. In this project, LED intensity is controlled by the LDR. Ethernet shield. It's basically control the Wi-Fi to the mobile and control Blinkit app as well. Temperature system. Temperature system is a control LM535 temperature sensor, heater register, cooler and temperature controlled by LM35 sensor. LCD. LCD is a display device, character liquid display device. In this, 2 lines and 16 columns of characters are displayed in it. LDR is a light dependent register. This is a part of LDR. Its connecting series 10K register. In this project, LDR is connected to A0, and this project is used control LED intensity. When the resistance is decreased, light LED is also decreased. When the resistance is increase of LDR, then the LED intensity is as well increased. Serial remote tank. Serial remote tank is a serial port is COM512. It's connected to them and it's controlled by Blinkit app, inlet outlet as well. Methodology. Block diagram. There is a Blynk IoT app, Arduino Uno, CLCD and temperature system. Arduino Uno is a basically IDE which is used to code, write code. Blinkit app is used to control heater switch and cooler. It's also notified the things which is right in code. Temperature as well is gauge widgets in the IoT app. Now it's run when the Blinkit app is on, heater switch widget button is on, and CLCD shows the notification and temperature as well. Temperature system is temperature display and the heater cooler as well is controlled by temperature system. Second part of block diagram. Volume of water, inlet well control, outlet well control, notify. Notify volume of water. Volume of water, inlet wall and outlet wall. Inlet outlet is controlled by the Blinkit IoT app. And the volume as well gauges widgets in IoT app. And notification as well, like full and less than volume. In a CLCD, show the volume of the water and as well show inlet outlet is on and off. Now goes to the simulation. It is my presentation video, but I see your actual simulation. This is a code which is the Arduino ID written. This thing is a Blynk app authentication token and template ID. This is a right which perform the functions in the code. Cooler function, heater function, inlet, outlet, temperature update, temperature 35 more than it's a turn off automatically. Handle the tank volume is less than 2000, its inlet is on automatically. If the volume is 3000 more, inlet well is automatically off. In the setup void, it's a single function it's performed. We write in setup. In a loop, we write in a loop, it's a continue control things. Ideal CPP. There is a many multiple files to open. This is a micros. Ideal is a garden light, which is a micro in a ideal H. Garden light is 3 pin and LDR sensor is A1. This is a defined micro. Here main.h is also defined micros. On F means 10, temperature goes V1, cooler V0, heater V2, water V3 as serial tank. In a serial tank, it's a volume, inlet outlet, disable outlet, controlled by this code. Here it's also micros defined enable 0100. These all are micros definition. Temperature system. Temperature system is a polar outlet output controlled by Blynk app. Here it is a temperature formula and Inot float 5 by 1023 float 0.01. It's a temperature formula. And temperature micros here defined heater pin 5 and cooler pin 4. Temperature sensor ANO. These all are the micros. Now go to Pixim simulation, but before compile it this code. See compiling sketching, then compiling sketch and export the binary. This is means hex file is generated, which is used in PICSIMLAB simulation. Now go to PICSIMLAB simulation. Here is PICSIMLAB simulation. This is the Arduino board. Go to modules, spare parts. This is a spare parts. This is a CLCD, temperature sensor, Ethernet shield, LED, LDR. Now open also a remote tank. Go to tools, serial remote tank. This is a serial remote tank. Now go to files and load the hex file as well. This is a hex file loaded, and go to spare part and serial tank. We set this all things. Connect the serial tank. Load the see. Here is automatically start the inlet. See this, and wait. We connect the phone as well to control the Blynk tab. I open the app to connect. See, my mobile is connected, and I open the Blynk app. This is my template. I on. Okay, and we start all things again. You see as well. Disconnect this serial tank. Reload the hex file as well. Reload the last hex file. Go to this and see this and see this also. You see here water volume is increased, outlet is on. If it goes to 3000 notification here, disable the out inlet automatically. You see 3000 is increased and water level is full, water level is disabled automatically. And I open the outlet well. When it's less than 2000 and inlet is automatically on and notification as well showed in notification section. Here it's see this less than is 2000 and water level is enabled. See this water level is enabled. I off and off. Now goes to the cooler and heater. I on the cooler, see this cooler is on and the LCD show of the cooler is on. I off the cooler is off the cooler. Heater on, heater on and see the temperature is increases. When the 35 is reached and the heater is automatically off. See this temperature is above 35 degrees Celsius, turning off the heater. This is a notification section. All these are the simulation process and the on the cooler instant the temperature is decreased. See this and the cooler off and see this cooler is off. All things this is a simulation. One thing or LED LDR, this is LDR. When the resistance is decreases, LDR LED is intensity is decreased. When the resistance increase, see this the LED is glow high intensity increase this. This is the LED glow. These all things are the simulation. Back to the PPT. This simulation video I show you. Now go to the conclusion. Conclusion is that I used the Blynk app. How to control the Blynk app. PICSIMLAB simulation. Simulate the home automation where LED at temperature, serial tank reassemble, LED heater cooler, real-time water tank is used, CLCD act as a dashboard, gauge widgets to display the temperature and volume water. All this my side. Thank you, friends.